This is Bob Capetta from the University of Illinois at Chicago, and this lesson is an introduction to power series. And this connects to the idea of geometric series that we looked at earlier. So what do we know? If we have a geometric series, that's a type of series where we have a common ratio. If that ratio is between -1 and 1, then that infinite series indeed converges to a naught over 1 minus r. So we want to extend this idea beyond simple geometric series to develop our notion of power series. So let's look at this example. If I have 1 plus x squared plus x cubed plus x to the fourth plus dot 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 forever. That is a geometric series. There is a common ratio between any two successive terms we multiply by x. From 1 to x, multiplied by x. From x to x squared, multiplied by x. From x squared to x cubed, multiplied by x. From x cubed to x to the fourth, multiplied by x. Common ratio is x. First term, 1. So if we're following our rule, then we would say that that sum would equal 1 over 1 minus x. But let's not forget when a geometric series converges. It converges when the common ratio is between -1 and 1. That's going to be important for us to recognize, and we'll call that an interval of convergence. We can also write this problem this way. Sum as k goes from 0 to infinity of x to the k. X to the 0 is 1, x to the 1 is x to the second is x squared, x to the third, x cubed, etc. So the sum as k goes from 0 to infinity of x to the k is 1 over 1 minus x, as long as that common ratio is between -1 and 1. So that's our interval of convergence. And when we're looking at these problems, oftentimes that's going to be one of our goals. Can we create a power series? And can we determine the interval of convergence? The radius of convergence is just half the size. So you'll notice this is centered at 0. From -1 to 1 is centered at 0. So the radius of convergence is 1 from the center out to the edge, 0 to 1. But the interval of convergence is the full range of values from -1 to 1. So let's look at that problem. We want to get a power series for this, and we want to establish an interval of convergence. So how are we going to do that? What do we know? What can we use? This is the fact. If we have a geometric series, the sum will be the first term over 1 minus a common ratio. So matching up the values here, a naught, the first term, seems to be 7. The common ratio here seems to be 2x. So if that's the case, we should be able to go ahead and express this thing as a power series. First term 7, common ratio 2x. Notice x is 0, 2x to the 0 is 1, 7 times 1 is 7, hence our first term. Common ratio is 2x. When k is 1, 7 times 2x. K is 2, 7 times 2x squared. K is 3, 7 times 2x to the third. So our common ratio is 2x, our first term is 7. So we indeed have come up with the power series, but do we have our interval of convergence? What do we need to know? The common ratio has to be between -1 and +1. So here's where we are. 2x is my common ratio. I want 2x to be between -1 and +1. Dividing both sides by 2 tells me that from -1/2 to +1/2, the common ratio will indeed be acceptable, and that is my interval of convergence. So we have our power series, and we have our interval of convergence. Let's look at a slightly more challenging one. If we have 5 over 2 plus 3x, and remember, we want to compare this to the formula for a geometric series, which is a naught over 1 minus r. Well, you can see our first issue is 1 is supposed to be on the lower left side of the denominator, and there's a 2 there instead. So what can we do mathematically to convert that 2 into a 1? And the answer is to divide the numerator by 2 and divide the denominator by 2. That will result in this. So dividing top and bottom by 2, we get 5 halves over 2 halves plus 3x over 2. Of course, 2 halves is 1, which now makes this start to look like that form, a naught over 1 minus r. So we get 5 halves over 1 plus 3x over 2. So it looks like our initial term, our a naught, is 5. Our r, it's plus, it's not minus. But we can think of plus 3x over 2 as minus negative 3x over 2. And indeed, our initial term, a naught, is 5 halves, and our common ratio is negative 3x over 2. So we want to use that to find the power series and to find the interval of convergence. So this is what we have. 5 halves, common ratio, negative 3x over 2 to the k power. K starts at 0. We're starting at 5 halves. K is 1. 5 halves times negative 3x over 2. K is 2. 5 halves times negative 3x over 2, quantity squared. Add up all those terms. We have our power series. So the last thing we have to do is we have to come up with the interval of convergence. And the common ratio must be between negative 1 and positive 1. So our common ratio is negative 3x over 2. I want that to be between negative 1 and positive 1. Algebra here gets a little tricky. We need to multiply by negative 2/3, but when you do that, multiply both sides by a negative number. Remember, you've got to change the sign of the inequality. Multiplying negative 2/3 times negative 1, I get 2/3. That sign switches because I multiply both sides by a negative. Similar thing here. Multiply both sides by negative 2/3 there. The sign switches. So normally we would write this negative 2/3 is less than x is less than 2/3. That will be our interval of convergence. Or using interval notation, the left endpoint, negative 2/3. The right endpoint, 2/3. We don't need to concern ourselves with the endpoints on a geometric series, because if r is 1 or if r is negative 1, a geometric series will not converge. And that will conclude this lesson.